Welcome back to The Explainer, everyone. Today, we're launching into an absolutely thrilling cosmic investigation. We're talking about a rare, high-stakes interstellar event, a literal stakeout in deep space that forced two massive, rival space agencies to team up on the fly. We're going to break down exactly how humanity pulled off an unprecedented dual spacecraft intercept of an alien visitor.
So what actually happens when an alien comet crashes into our solar system? It's the ultimate sci-fi question, right? But here's the thing. This isn't some theoretical scenario or a Hollywood movie pitch. This just happened. A rogue object from a completely foreign stellar system plunged into our neighborhood. And instead of just watching it streak by, our scientists set a trap to catch its chemical fingerprints.
Okay, let's dive into this. Section 1. An alien visitor arrives and the discovery of 3I/Atlas.
Discovered in July 2025, Comet 3I Atlas became only the third known interstellar object to ever enter our solar system. Because it was basically dropping in from the cosmic void, it was moving incredibly fast. Now, it made its closest approach to the Sun just a few months later, right around October 2025. And this posed a massive problem for astronomers. During its closest approach, which, is when a comet is usually the most active and spewing the most material, it was on the other side of the Sun, completely hidden from our Earth-based telescopes. It was a fleeting, speeding target, and we were desperately wanting to observe it, but we were effectively blind to it from the ground.
Which brings us to Section 2, the ultimate space stakeout. Talk about being in the right place at the right time.
Let's take a look at the players involved in this deep space mystery. We had two multi-billion-dollar probes currently cruising through the void. NASA's Europa Clipper, which had just launched in October 2024 and was using Mars for a gravity assist, and the European Space Agency's JUICE probe, which launched in 2023 and had just completed a Venus flyby. Both of these spacecraft are bound for Jupiter to study its icy moons. But more importantly, both are armed to the teeth with advanced ultraviolet spectrograph instruments, or UVS. And the masterminds who actually realized this, the researchers at the Southwest Research Institute, who just happen to have scientists deeply involved in both missions.
Dr. Kurt Rutherford from the Southwest Research Institute really summed up the sheer audacity of this plan perfectly. He said, as the comet passed between JUICE and Europa Clipper, we were able to informally coordinate observations. I really want you to appreciate the incredible luck and brilliant coordination this required. You've got two highly regimented space agencies, ESA and NASA, and the SWRI team basically said, hey, this alien comet is about to thread the needle right between our two Jupiter probes in November 2025. Let's point both of them at it.
All right, Section 3, a coordinated cosmic intercept, the pincer movement. Now, because of their unique positions, these two spacecraft actually pulled off a simultaneous pincer movement on the comet. And this brilliantly illustrates how capturing the comet from two completely different lighting angles at the exact same time was a massive first in astronomy. JUICE had an incredible view of the comet's day side, directly observing the glowing gas emissions as hydrogen, oxygen, and carbon broke apart in the sunlight. Meanwhile, Europa Clipper caught the night side, capturing high-contrast images of scattered dust trailing off into the darkness.
And the scale of what they saw? Staggering. The UFS images revealed that the gas and dust trailing from the comet stretched at least 5 million kilometers from the nucleus. I mean, to put that into perspective, that is over 12 times the distance between the Earth and the Moon. Just a massive glowing trail of alien material burning off into our solar system.
Moving on to Section 4, the waiting game and the suspense of deep space data.
So the simultaneous intercept goes down in November 2025, right? But getting this data wasn't instant. It was really like the cliffhanger of our heist. See, JUICE was traversing the inner solar system in what's known as its hot cruise phase. To survive the hellish heat near Venus and Earth, JUICE actually had to use its large high-gain antenna as a literal physical sun shield. Because the antenna was pointed at the sun to block the heat, it couldn't point at Earth to transmit the massive packets of image data. It wasn't until mid-January 2026 that the probes entered their cold cruise phase and the data finally poured into Earth's receiving stations in February. It was a frustrating 3-month cliffhanger.
But the wait was worth it. Section 5, decoding the alien dust and finding its chemical footprint.
So, the really crucial point here is the sheer volume of material. Using advanced instruments like the Moon's and Jupiter Imaging Spectrometer, or MAGIS, JUICE detected a staggering 2,000 kilograms of water being released per second from the comet on November 2nd. 2,000 kilograms a second. And thanks to another onboard sensor called the Submillimeter Wave Instrument, or SWI, they found that a massive chunk of this water wasn't just boiling off the surface of the nucleus directly, but was actually sublimating out of the icy dust grains floating in the comet's comber.
But water is really just the beginning of the story. Let's compare 3I Atlas to the comets native to our own solar system. Native comets from our Oort cloud or Kuiper belt have standard baseline levels of carbon and trace amounts of methane. 3I Atlas, however, showed unexpectedly high levels of carbon emissions. And this wasn't just some anomaly. A few months later, in June 2026, the James Webb Space Telescope locked onto the comet and detected robust methane signatures in its outgassing. This proves conclusively that 3I Atlas formed in a very different, highly carbon-rich molecular cloud somewhere else in the galaxy.
And as Dr. Philippa Molyneux pointed out, by studying the ratio of these chemicals, this helps us understand if the solar system where 3I Atlas formed is similar to ours or different. This is absolutely crucial because we aren't just looking at a rock here, we are basically reading the chemical DNA of a totally alien solar system delivered right to our doorstep.
Section 6. Clues to alien worlds and the ingredients for life. Let's connect this back to the fundamental question of how life forms. Now, what's really interesting about this is how it connects to our own cosmic backyard. Recently, NASA's OSIRIS-REx mission brought back pristine samples from our own native asteroid, Bennu. Inside Bennu, scientists found 14 of the 20 amino acids required for life, all 5 nucleobases for DNA, and water-rich salts. It proved that the chemical precursors for biology were basically cooked up in deep space before Earth even formed. Now, pair that with our alien visitor, 3I Atlas. We just watched it vent 2,000 kilograms of water a second, loaded with carbon and methane, the exact same foundational building blocks. It strongly suggests that complex organic chemistry isn't unique to our solar system. These same organic precursors might be churning in the deep space environments of alien systems all across the Milky Way.
Which brings us to our final section, Section 7, the search for life beyond our solar system. I want to leave you with this final, provocative thought. If a totally random interstellar visitor, violently ejected from its home star millions of years ago, is still this incredibly rich in water, carbon, and the organic precursors for biology, what does that mean for the planets in the alien world it left behind? Are the building blocks for life just waiting on every icy moon in the galaxy? It's a fascinating question. And thanks to the brilliant data from this unprecedented cosmic stakeout, we are one step closer to answering it. Keep looking up, keep asking questions, and be sure to subscribe for more deep dives on The Explainer.